Problem 36, method 2. So I'm supposed to evaluate the indefinite integral of cos 3x sine 5x dx. So I've already evaluated when I make u be equals to cos x. So now I want to see and check my answer using or letting u be equals to sine x. So next I will find the derivative of u, which is du, with respect to x. So I know that the derivative of sine x is equals to cos x. This is according to the rules of the calculus trig functions that we've already identified for differentiation and integration. So after this, I want to separate my du from my dx. So I will cross multiply. So this then becomes du is equals to cos x dx. So here I've separated du and the x values on one side. Because I now have this, the next thing I want to do is to rewrite my expression. So my expression is evaluating the integral of cos 3x sine 5x dx. Okay, because I'm working with trig functions, I want to apply trig identities. So the identity that I will apply here, Pythagorean identities, is one that relates cos and sine x. So I already know that the identity is cos 2x plus sine x squared is equals to 1. So because I've already expressed everything in terms of cos x, so I'm letting my u be sine x and the derivative is cos x, so I will then try and find out the derivative with regards to the identities here so that it's simpler. So it will be cos squared x, which will be equals to 1. Then I take the sine to the other side, sine x to the other side, it will be minus sine squared of x. So now I have cos squared x is equals to 1 minus sine squared x. This is how they relate. So these two are the same. Then I've already have my u being sine x, so it will be easier to then work with. So now I have a problem. My trig identity is working with even numbers, but in my equation I have odd numbers. So how do I solve this? What I do is I am going to change these odd numbers to even numbers by doing this. So it will be cos x, cos squared x multiplied by sine 5x dx. I'm not going to change the sine x because I said let u be sine x. So this will be taken care of by that aspect of the equation. So this then becomes, so if you check here, cos x multiplied by cos 2x is the same as cos 3x because when the bases are the same, I simply add the exponents. So here, because now I've got a cos 2x, I can apply my trig identities. So this then becomes cos x, open bracket 1 minus sine squared x sine 5x dx. When you looking at this, you can already see that I didn't change anything. It's cos x into this. 1 minus sine squared x is the same as cos squared x. Sine 5x, I just carried this over because I'm saying that let u be is equals to x, so I'll be able to work with this. So from here, I want to express everything in terms of u so that I can apply u substitution. So above, here, I've already determined that du is equals to cos x dx. So how can I apply this in this equation? So looking at this equation, I can see that there is a cos x here, and then there is a dx here. So which means that I can simply rewrite this as 1 minus sine squared x sine squared x close bracket cos x dx. Because I've rewritten this as this, you can see that this expression, the du is equals to cos x dx. So now I have a cos x dx. So now I want to express everything in terms of u so that I can apply u substitution. So it becomes integrating 1 minus, I've already said that let my sine, let my u, okay, let me just take this step by step. So this will be sine squared x, close bracket, sine 5x multiplied by cos x dx. Sorry, here I forgot to carry over the sine 5x here. Okay, so now what you can see here is that I have my x values, but I want to express everything as a u so that I can be able to apply u substitution. So looking back, like I was explaining here, that since I already know that du is equals to cos x, and then in this equation, I also have a cos x. So which means I can make my cos x dx equal to du, and then use u substitution. So this becomes 1 minus, because I said that my u, let my u be equals to sine x, I can say this then becomes the u. I put back the square, and then I say u exponent 5. And then instead of cos x dx, I can then write du, because cos x dx is equals to du. Now everything is expressed in terms of u. So let me further simplify this equation. Then this becomes, if I FOIL this part, this will become 1. This will become u. 1 multiplied by u to the exponent 5 becomes u exponent 5, because any number multiplied by 1 is 1. Is that number. That's a multiplicative identity. So here I have a negative sign and a positive sign, so it will become negative u exponent 5 multiplied by u exponent 2. So the bases are the same. I rewrite the base, I add the exponent, close bracket, du. So what does this expression then mean to me now? It means that I can rewrite this expression as integrating u exponent 5. Then if I FOIL this, it will be the same expression still. So it will be u exponent 5 du minus integrating u exponent 7 du. So this is the same thing. I didn't change anything. I just FOILed this. I just did this. And then I separated what resulted from that. So it's integrating u exponent 5 du minus integrating u exponent 7 du. So now I'm going to apply the power rule for integration. The power rule for integration tells me that if x exponent n plus, it says x exponent n plus 1 divided by n plus 1. So it is the opposite of the power rule for differentiation. So now to apply this, what it simply means is that on the exponent, I just add 1, then divide by that value that I get. So it becomes integrating. It becomes this equals to cosine u exponent 5 plus 1 is equals to 6 divided by 6, cos n plus 1, n plus 1. And then let me rewrite du minus integrating u 7 plus 1 is 8. This is divided by 8, and then I write my du. Because I've evaluated using the power rule of integration I've evaluated this expression. This falls away, this integration sign, and the du falls away, du, and the integration sign falls away. So this expression then becomes u exponent 6 divided by 6 plus u exponent 8 divided by 8 plus some constant c, which is a constant of integration. So this is the constant of integrations here. All right, constant of integration. Okay. So now that I have this, and I've already determined that my u is equals to sine x, it means that I can simply substitute sine x into these values here. So what I get is sine 6x all over 6 plus sine 8x all over 8 plus some constant c, which is the constant of integration. So now I see that my value is evaluated using u substitution. Thank you so much for joining me as I study how to solve this trig function using method 2 of the study guide. So just a brief summary on what I have learned in this one. Remember, I am letting my u be equals to sine x here. So it means that I'll be working on my cos x and applying the trig identities. After this, I will find the derivative of sine x, which is equals to cos x. Then I will separate the two parts of this. After separating them, I will then apply trigonometric identities, which is the Pythagorean identities. Let me write Pythagorean identities here. Pythagorean identities. And then to simplify this, because I'm working with even numbers here and an even number, but it's odd, I'm going to separate these two. So I'm going to say cos x multiplied by cos squared x, because when I've done that, I am able to then apply these identities here. Then after that, I then put this value that I found here, which is 1 minus sine squared x, which I put here, which is the same as cos x, as you have seen here. Then I put back my sine 5x dx. Then I continue, and then I want to express everything in terms of u. Because I'm expressing everything in terms of u, I then rearrange my formula to say cos x dx. But I've already identified that cos x dx is the same as du. So instead of cos x dx, I put du here. So after that, it was easier for me to then apply the power rule for integration, which is this one. And then I integrated it. After integration, I know that the signs fall away. So this sign fell away, the du, the sign fell away along with the du. And then after that, what I got is this u expression here. And then I already know that my u is equals to sine x. So I then substituted with my u and found my final answer to be sine 6x all over 6 plus sine 8x all over 8 plus some constant c, which is the constant of integration.